Good day, everyone. We're still busy with integrating odd powers of trigonometric functions from math physics. And the power here is the power 5. So, as I told you in my previous video, tan and cot, I put them in the same family. As far as the power 5 is concerned, when I'm breaking the power 5, I take my time, I break it to this format. Power 2 times power 3. Then I go further to break the power 3 like that. So there are many other methods, but this is the method I want to show you. So that can then take us to the problem. So we want to integrate cot to the power 5. So as my first step, I will call it cot squared. Now the target here is the angle. What does it mean? X over root 2. So you have to separate that x from the root 2 so that you get 1 over root 2 x. So if you handle it like this, then from the formula sheet, it will be easy for you to know that where there is cot square ax, you'll be writing a will be 1 over root 2. So I've got cot square 1 over root 2x multiplied by cot cube. My angle will be 1 over root 2x. So that is my first step, which is like moving from the power 5 to a squared times a cubed. Then after that, I need now to look for a formula for cot squared. So for cot, just like tan, there is only one formula for cot squared, which is coming from formula number 3, page 1 of the formula sheet. So if I need cot squared, I use this formula and make cot squared the subject. Whether I'm working with even powers or odd powers, it doesn't matter. So I will make cot squared the subject there. So if I make cot squared the subject, it will take me to 1. I have to go this side, so cosec squared minus 1. So I get cosec squared 1 over 2x minus 1. That's what we replace cot squared. Then multiply by cot cube 1 on root 2x dx. So that is what I've done in the second step. After applying that, then from here, open the bracket to create two different integrals. This one multiplying there and multiplying there. So we'll do just that. We'll open the bracket, we'll get cot cube going there. So I'll get cosec squared 1 over 2x multiplied by cot cube 1 over 2x dx. That's my first integral. Then followed by the subtraction sign. Then I get the integral of this also goes there. I get cot cube 1 on 2x dx. So this one at this stage it's now ready for integration because this is a product. And you see, if you differentiate cot, you get cosec squared. So my target now is here. That's what I meant by if I split it this way, I'll then go further to split this one. So we're now going to split this one. That means for now I'm copying this one the way it is. So this one will remain cosec squared 1 over 2x times cot cube 1 on 2x dx. So that's the same term. Then when I go here, I split this one again, just like that. So this becomes cot squared 1 over 2x multiplied by cot 1 over root 2x dx. So that is now handling this portion. Then after, I will look for the meaning of cot squared from the same formula, just exactly as I did it over there. So now moving on, I will then continue this side. So when I move on, I copy the first term exactly the same way. So it's cosec squared 1 over 2x multiplied by cot cube 1 on 2x dx. Then minus the integral of, so for this one, I look for the meaning of cot squared, as I've explained earlier. I'll just copy that one, which is coming from this formula, page 1, formula number 3 of the math physics formula sheet. So that will be cosec squared 1 on root 2x minus 1 multiplied by cot, this one, 1 over root 2x dx. Then finally, I will make it 3 different integrals cube 1 on 2x dx. Then for the second integral, I must remember that this will multiply here with a negative sign, so that gives me negative the integral of cos x squared 1 on 2x times cot 1 on 2x dx. Then finally, the last integral will be a positive. You see there are two negatives, and that cot will go there to give me a positive. The integral of cot 1 on 2x dx. So those are our three terms. It's obvious that the last term is not a problem, because from page 2 of our formula sheet, we'll just look for the integral of cot ax on page 2, column number 3. So our target here is the first two, which are product. And in this product, you'll see there is such a way that if you differentiate cot, you'll get the whole of cos x squared. So that means I can do u substitution. Once you get a product where you can differentiate something to get the other one, it's u substitution. It's the same thing here. And the best option to take your u will be to say let it be cot, because when you differentiate cot, you get the whole of cos x squared. If I take u as cos x and differentiate it, I cannot get cot cube, I cannot get cot. So that won't be a smart option to take. So in that way, I'm going to use the power rule to help us go through this. So what does the power rule say? It's a formula on page number 4 of our formula sheet, which we use it in the place of u substitution. So that is the nature of the formula, and this is the smart way to go for an N6 student if you want to work fast. So each time you have a product and you are convinced that it's u substitution, whatever is supposed to be a u, you just put it in the position of f. Like we have agreed here in this product, the best option for you will be to say let u be cot, since the derivative create the whole of cos x squared. So I'll just take that cot, put it in the place of f in that formula. That formula is on page 4 of the Math N6 formula sheet. So I'm doing that, I'm putting cot 1 on root 2x here. So you see the formula has an n, that n will be the power of cot in the original problem, and the power of cot is a 3. Then it has to be followed by the derivative of what you place here, the derivative of cot. If you are looking at the formula sheet page 2, the derivative of cot ax should be negative 1 on a, our a is 1 over 2, cos x squared 1 on 2x, then dx. So that is what we have to write. What I've written here is based on what the formula wants. But now, our target is u substitution. So to make sure that our u substitution is complete, whatever we've written here must match the original problem. So if I start comparing, you see cot cube exists, cos x squared exists, but negative 1 over 2 does not exist in the original. So to make sure the two are still the same, I just need a number that can take care of the negative 1 over 2. So when I say take care of, it means if I get negative 1 over 2, what number will I multiply with to get 1? You see that number must be negative over 2. So if I can go outside and put my negative over 2 out, then I'm done with your substitution for this particular term. So it is as if I'm done with my u substitution already. And if I want to write my answer for this first integral, I just look at the right hand side. Remember, on the right hand side you still have the f of x that was appearing there. So whatever you place here, if you also place it here, then you are writing your answer. So let's just try to write our answer for this before we move to the next to see how it works. So for the first, if I'm writing my answer for any integral, all I need to do is anything that we wrote out of the integral sign must be in your answer. So you see we've got root 2 out of the integral sign. So to write my answer, all I need to do is the cot that came here must also go there. So that is it. So I will now have cot. Now the power will increase, you see, from n to n plus 1. So the power will be 4. I get my 1 on root 2x, then I divide by 4. So with this particular first term, I'm done with the integration. So let's now move to the next step. How do we now integrate this way? To do this, I just follow what I've done here. Start by comparing what is here to what is here. If you look at the first term and the second term, you see the only difference is that the cot here has a cube, this one, the power is 1. which therefore means whatever I did here, I must do it here. And I can still remember what I did here. I started by putting a negative root 2 out. I'll just copy all of this and paste it. So it's like doing the same use substitution. I don't need to be even looking at the formula again. I just copy and paste. So if I copy from negative root 2, it combines with this negative, it will now give me positive root 2 out. The integral of the here, I get my cot 1 on root 2x. So that cot, the power will now be a 1 because the power of cot here is a 1. Since we need to know what will take the place of our n. Our n is always the power in the original cot. Here it was 3, here it is 1. Then I'll multiply this by negative 1 on root 2 cosine squared 1 on root 2x dx. So again, for the second integral, if I want to write my answer, all I need to do is this cot that I put in the place of f on the left, I will do it the same thing on the right. So for this second, my answer is 2 into, I will then take my cot, if I put it there, the power will increase by 1 to 2, the angle is 1 over 2x. So for the second integral, then I divide by 2 also, because you increase the power, you divide by a new power, as the formula is saying. So for the second integral, I'm done. And for the last one, you know, it's just a matter of copy from page 2 of the math NC's formula sheet and paste. So if I go to the last one, I go to page 2, and look for how to then integrate cot ax, where my a is 1 over root 2. So on my page number 2, towards the bottom of the page, the integral of cot ax is 1 over a, so it's supposed to be 1 over a. My a itself is 1 on root 2, so that is 1 divided by 1 on root 2, which normally should just be root 2. Then the ln of sine ax, my a is root 2x plus. So guys, this is how simple it is to get your answer. So if I now want to write in a more friendly manner, then it will just be negative root 2 over 4 cot to the power 4 1 over root 2x for the first term. I'll just take negative root 2 over 4. Then here is positive root 2 over 2. Then you get your cot square 1 on root 2x. Then for the last one, 1 divided by 1 over root 2 is a positive root 2 ln sine 1 on root 2x plus c. So this last part, you can just do it if you want to. If you are not comfortable, if you don't have time for that, you just anything. So guys, this is how we do the integral of cot to the power 5. Thank you very much.